Hello out there, it's Dallas Online again, and we'll be talking about advanced mathematics, and the specific topic as it's seen out there, you'll see trigonometry, specifically in trigonometric identities. So be with me as I'll be presenting to you. My name is Kimati John, and we will cover the following. First of all, we shall define what are the identities, and then after that we shall try to derive the Pythagorean identity, that is sine square of x plus cos of x square is equal to 1. And then after that we shall try to simplify some trigonometric identities, and then we shall try to solve some equations, and then after that we shall try to prove some identities if possible. Now, what is a trigonometrical identities? Trigonometrical identities are trigonometrical expression connected together to form a useful relationship between a basic trigonometric functions, including their reciprocals. So I can repeat that. Trigonometric identities are trigonometric expressions connected together to form useful relationship between basic trigonometric functions, including their reciprocals. And we know the trigonometric functions, or the trigonometric functions that we have sine, we have cosines, and so forth. So when they are connected together to form a useful relationship, we call them trigonometric identities. For example, we have a trigonometric identity as it is in there. We have sine square of x plus cos square of x is equal to 1. That's one of the trigonometric identities that we know. And the next one, that is tan square of x plus 1 is equal to sec square of x. That is also another trigonometric identity. But also we have a cos 2x is equal to cos square of x minus sine square of x, and so forth and so forth. There are so many more trigonometric identities that are very useful while trying to study things in trigonometric, in a topic so-called trigonometry. So let's derive a trigonometric identity as it is in there. One of them is sine square of x plus cos square of x is equal to 1. And this is so-called Pythagorean identity. And we have a lot of other Pythagorean identities, but the basic one is that one. So let's derive and see how it looks like. Now let's have a xy plane with a coordinate, let's say p, that is x comma y, meaning that the plane, that point P makes the angle x with the x-axis, and that is x-axis, and that is y-axis. Now, the distance from that point to that point, that means where x falls, it is so-called the distance x, and we have that distance so-called distance y. That means from where y is equal to 0 to that point P is so-called a y. And we can call that side as r. We can assume that that point rotates. That means that will be a radius of that cycle where it rotates. That means you can call it r. Now let's see. We know that sine, if we say sine of x equals to what? Sine of x, we know that sine is equal to opposite over hypotenuse, and our opposite there is y, and our hypotenuse is r, meaning that, implying that we have a y equals to r sine x. What about cos of x? Cos of x is equal to adjacent of hypotenuse, and our adjacent there is x over r, implying that x is equal to r cos that thing. Now let's remind ourselves what is Pythagoras theorem says. Now by Pythagoras theorem, we know that x square plus y square is equal to r square. That is our right angle triangle. If we try to assume that is our right angle triangle, and this is our hypotenuse, and that is our adjacent, that is our opposite to that angle. That means x square, this distance square, plus that distance squared, the sum of that is equal to that distance, so-called hypotenuse squared. That means that is our relationship. Now let's find the value of x square sine square, y square, and we will. Now let's find the value of x square and the y square, and then we'll see what happens. So we have, from that point, we have a y equals to r sine x, implying that if we square both sides, we have y square, which equals to r sine x, and that's all squared. That is to say, we have y square, which equals to r square sine x square. What about our x? That means we have x, which equals to r cos x, implying that squaring both the sides, we have x square equals to r cos x, and all of that is squared, implying that we have x square, which equals to r square cos square of x. Now let's find the value of x square plus y square. So we can call that equation 1, and that is equation number 2. So that means adding the two, we shall have the following. That means we shall have the following from this. That means we know that is x square plus y square is equal to r square. That means x square, or x square is what? Our x square is that thing, is r square cos x square, plus that thing there is r square sine square of x is equal to r square. As you can see there, r is common throughout. That means we can divide by r square. That means we shall have r square cos square of x over r square sine square of x over r square is equal to r square divided by r square. That means r square and r square goes. So as the rest ones, that means we are going to be left with cos square of x plus sine square of x is equal to 1. So that is our identity, and it is so called the Pythagorean identity. And we have a lot of other identity with other names, double angle identity, half angle identities. We shall see as we go on, but this one is called the Pythagorean identity. That's how we can derive it. Now we can also find other identities from there. I do hope you understand, as I'm trying to remind you of that. Now let's see what will happen if we try to divide that by cos square of x. What will happen if we try to divide that by cos square of x? So we have cos square of x divided by cos square of x plus sine square of x divided by cos square of x equals to what? 1 divided by cos square of x. That means cos and cos goes. That means we are left with 1. Then there we are left with sine square over cos square of x. That means it's tan square of x equals to 1 over cos square of x. It is sec square of x. That means we have another identity there. So we have this one, and the second one is that one. Can we also go on? Okay, let's go on. So again, we can divide that Pythagorean identity as we derived by, there we divide by cos square. Can we divide by sine throughout, sine square throughout? So we have cos square of x plus sine square of x is equal to 1. So let's divide by sine square throughout. So we have sine square of x, sine square of x, sine square of x. So what are we left with? There, that means we have cot square of x. As we know that sine divided by cos is tan. Sine divided by cos is tan. That means if it's cos divided by by sine, that means it's a reciprocal of tan, that is cot. That means we have a cot square of x plus 1 is equal to reciprocal of sine square. We know that is cosec square of x. In other books, they just write CSC, and in other books, they write cosec as it is seen there. So I will use that one. So we have another identity, and we'll be using those identities as we go on. We just use them. So we come across something where we can apply such kind of identity, then you apply that identity. You come across where you can apply this identity, then you apply it. You come across where you can apply this, so as you apply that. So as I said, we have other identities as a double angle identities, and I hope you know what are double angles identities, and we have half angle identities and other identities as you know they are there. Now let's see how can we solve, or how can we simplify. Now let's see how can we solve or simplify or eliminate parameters as we go on. Let's go on. We have the first example, or the first set of example that says prove the following identities. We have tan square of x over 1 plus sec square of x is equal to sec of x minus 1. We have the example. Example number 1 says tan square of x over 1 plus sec x is equal to sec x minus 1. We are supposed to prove that. So we have a lot kind of identities that sometimes ask you to prove, to show, to simplify. You have to understand what you are supposed to do. And I will explain something here. To prove, that means you have to take one side and use that one side to prove that is equal to another side. Let's say you choose from right hand side. That means you are to use that right hand side to show that is equal to the left hand side. To show you can use both sides. For example, if that question asks us to show, that means we can use both sides. We can take from the left hand side and simplify up to somewhere, and then we take the right hand side and simplify it somewhere else. That means if the right hand side is equal to the left hand side, that means we are there. We have shown the identity to be true. And sometimes you have to simplify. That means you have been given a certain kind of certain complexity. That means you have to express it in its simple form. So we shall see one case after another if time allows us, and let's see one example. So we have from our example, tan square of x 1 plus sec x is equal to sec x minus 1. Sec x minus 1. Now, the example tells us to prove. That means we have to choose. If we start from the left hand side, that means it should be equal to the right hand side. We have to use only one side. But if we are supposed to show, that means we could take the left hand side up to somewhere and the right hand side up to somewhere, and if they are equal or if they resemble, that means we have shown the identity. But our question tells us to prove. That means we have to take only one side. Now let's say from left hand side. That means from left hand side we are taking this part. That means we have to manipulate that part up to when we reach to that part. That means we have tan square of x 1 plus sec x. So what is this? That means we have to use that part to reach the other part. Now, can we use that tan square? Because we know that from our identities we have an identity that has tan square in it. And if you remember that much correct, we have that there. That means our tan square of x can be equals to what? So we have tan square of x equals to sec square of x minus 1. sec square of x. That means instead of writing tan square of x, now I'm writing sec square of x minus 1 over, we have 1 plus sec x. So instead of writing now tan square of x, I have seen that I can write that. So these are the use of identities. Instead of writing that, I can use that. Now let me simplify this. As you can see there, you can use the concept of different of two squares, and that is to say, we are going to have sec x equals to what? Sec x plus 1 over 1 plus sec x. 1 over minus plus sec x. As you can see there, this and that one are equal. This and that one are equal. That means this and that can go. And what are we left with? We are left with sec x minus 1. As you can see there, we were told that to prove this one is equal to that one, and as you can see, we have reached the destination. That means we are supposed to conclude the question. We are supposed to conclude the question. Most of the students do forget to conclude the question, and our conclusion is very, very simple. We use the left hand side. That means we are supposed to show that to prove that it is equal to the right hand side. That means our conclusion will be therefore we have left hand side is equal to right hand side. Thus tan square of x 1 plus sec of x is equal to sec x minus 1. That is our conclusion, my dear student. I do hope you follow as I'm trying to explain this. Now let's check the second example. The second example tells us that sine square of x plus 2 cos x minus 1 over sine square of x plus 3 cos x minus 3 is equal to 1 over 1 minus sec x. So we are supposed to prove that. So if you try to use the left hand side, then you are good. That means you are supposed to reach this point. And if you try to use that left hand side, that means you are supposed to reach the right hand side results. So let's see how it goes. So our example says sine square of x plus 2 cos x minus 1 sine square of x plus 3 cos x minus 3, it should be equal to 1 over 1 minus sec x. So we are supposed to prove that. That means if you choose that side, or if you choose that side as I explained earlier, then you have to use only one side. Now let's see. Now from left hand side, I've tried to choose that side. And left hand side, what do we have? We have sine square of x plus 2 cos x minus 1 sine square of x plus 3 cos x minus 3. Now what is that? As you can see there, we have a sine square, and also there we have a sine square, but there we have a cos, and there we have a cos. Can I simplify that from the identity that is sine square of x plus cos square of x is equal to 1? Can I simplify that and get the sine square of x? As we know that sine square of x will be equal to 1 minus cos square of x. That means instead of writing sine square of x, I will write that one. Let's go and see that. So we have 1 minus cos square of x plus 2 cos x minus 1 over 1 minus cos square of x plus 3 cos x minus 3. And how can we move from there? You can see this one and that one, this is positive and that is negative, that means this one and that one can go. And this one and that one, this is positive, that is negative, that means we are left with a negative 2. So let's write that much correct. That means we shall have, let's say, 2 cos x minus cos square of x, so that I did not forget that negative, that's why I've written that way, over this one and that one, that means we are left with 3 cos x minus cos square of x minus 2. And what can we do from there? If you try to look that much careful, let's say u equals to cos of x. That means you will be left with 2u minus u square, then 3u minus u square minus 2. But remember that u will be replaced or will be returned back after we have finished our proof. Now let's, from there, this is a quadratic expression. As you can see there, you have a coefficient of x square, you have a coefficient of x and a constant, and also that is a quadratic expression. You have a coefficient of x square and a coefficient of x. So let's see. Can we factor out u there? So we can have u, then 2 minus u over, but down there we have a quadratic expression, and writing that much correctly, that is u square plus 3u minus 2. What can be the factors there? So we have a u square plus 2u plus u minus 2. So factoring out a negative u, what are we going to be left with? We're going to be left with u minus 2, and then factoring out the positive 1, that means we are left with u minus 2. Then finalizing that, we are going to be left with minus u plus 1, u minus 2. So let's, instead of writing that expression, now we are going to write this one. That means we are left with negative u plus 1, u minus 2. As you can see there, this and that resembles, but it misses a very minor thing, a very minor thing. Now let's move on. That means if we try to exchange the position of that, we are going to be left with, or if we take a negative out, we will be left with a negative u minus 2. Then there we have negative u plus 1, u minus 2. That means this and that one will go, and we'll be left with u, negative u plus 1. That is to say, we are left with negative u 1 minus u. And what was our u? Our u was cos of x. That means we are left with, replacing a u, we have cos of x, 1 minus cos of x. Can we divide that by a negative cos of x? Then we are going to be left with, that means on top there, negative over 1 minus, over 1 over, that is negative cos of x minus cos of x over cos of x. then we are left with what? On top there is negative over negative, that is a positive 1. That means there is 1 over cos, but negative, that means is negative sec x. And there we have a negative, that means negative and negative, we have a negative there, that means negative and negative will be positive 1. Writing that much correctly, we are going to be left with 1 minus sec x. As you can see, the results from left hand side are equal to the results from right hand side. That means, let's conclude, therefore left hand side is equal to right hand side, and that expression is true. That means, therefore, sine square of x plus 2 cos x minus 1 over sine square of x plus 3 cos x minus 3 is equal to 1 over 1 minus sec x. And that is how you conclude the question. Okay, now we have the next example, that is example number 3, and we are supposed to prove that. That means the under root of 1 minus cos of theta over 1 plus cos of theta is equal to the absolute value of cosec theta minus cot theta. We are supposed to prove that. Sometimes one of the parts can be hidden, so that you are supposed to simplify one of the sides. Also, for example, there, if you hide that part, that means you can be told to simplify the other part. Or if that is hidden, that means you are supposed to simplify that. That is how things are. Now let's do that, the third example. So we have the under root of 1 minus cos theta, 1 plus cos theta is equal to the absolute value of cosec theta minus cot theta. We are supposed to prove that. Now from a solution, in this case I will start from, now choosing the side to start, you have to understand, you have to choose the side that is easy for you to manipulate, that you know how you can manipulate. You can't choose a side that you don't know the identities that are used there. So choose a side where you are comfortable to manipulate and where you are comfortable to go on. Now from right hand side, I've decided to take that side. That means we have the absolute value of cosec of theta minus cot of theta. We know that the definition of absolute value, for example, you have the absolute value of x. What the definition to this is the under root of x squared. This is the definition. That's why we always say the number comes out positive, the number comes out positive, but this is the definition. The number goes in there, is squared, and then is found the square root of it. Now that is the definition. So I can use that here. So I will just use this one. And this will be, all of this is cosec theta minus cot theta, but all of that is squared. That is absolute value of that is equal to that. That means we can simplify that. And simplifying that, I have decided to do the following. This is equal to 1 over, this is found by 1 over sine theta is called cosec theta minus, and this is the reciprocal of tan. That means is cos theta over sine theta, and all of it is squared. Now let's go on. That means it's the under root. If we try to add the 2, that means we are left with sine theta minus this times that one, and this times that one, over sine square theta, sine theta, sine theta. And all of this is squared, and all of that is squared. Now let's simplify that once more. Now from there, the next step, I will try to fact out the sine out of the brackets. Now let's see. If you fact out, that means is equal to. If you fact out that sine, that means you are left with sine theta. That means there we are left with 1 minus cos theta, 1 minus cos theta over sine, but this is squared. That means squared theta, and all of this again is squared. Now let's manipulate that. That means from there, what are we left with? We are left with sine square theta in brackets 1 minus cos theta, and all of that is squared, and all of that is squared over sine raised to 4, because it's square, sine square of theta. That means squaring it, you have sine raised to 4 theta. That means I have already used the square there. The square there, I've used it. Now let's see. We have a square there, and then there we have raised to 4. That means the 2 from there and the 2 from there will go. That means we'll be left with. We have 1 minus cos theta, and all of that is squared, sine squared theta. Now from there, let's simplify that. We know that that is equal to the under root of 1 minus cos theta squared over 1 minus cos square theta, because we know that from Pythagorean identity, as I will show earlier, that sine square theta plus cos square theta is equal to 1. So taking a cos on the right hand side, you will be left with this one. Now you can see there, these are different of 2 squares. That means we are left with 1 minus cos theta squared, 1 minus cos theta, 1 plus cos theta. That means we have 1 minus cos theta, they are doubled up there, and we have 1 down here. That means we are left with what? So if we take that one there, that means, and that one goes, that means we'll be left with the under root of one of them, that is 1 minus cos theta over 1 plus cos theta, 1 plus cos theta. That means, concluding our question, we started from the right hand side, and we have to prove is equal to the left hand side. That means, therefore, left hand side is equal to right hand side, and that means the under root of 1 minus cos theta 1 plus cos theta is equal to the absolute value of cosec theta minus cot theta. That's how we conclude. Remember to conclude. Remember to conclude, because this question needs conclusion. So remember to conclude. That's how we conclude that kind of questions. Let's see the other examples. Okay, we have a lot of identities to prove. We have a lot of identities, a number of them out there. Find books and do a lot of questions, a lot of identities to prove. And there we have some other examples that tells us to prove. I will try to find one so that we can, I will do the third one. that tells us to simplify. And what are we supposed to simplify? We're supposed to simplify 3 minus cot x, and all of that is squared, plus 1 plus 3 cot x, and all of that is also squared. So as I said earlier, we have 3 vocabularies that are used there. We have simplify, we have proving the identity, and we have to show the identity. So we have to use different techniques on doing such kind of questions. And this one tells us to simplify. We don't have the right hand side, we don't have the right hand side. We are told to simplify this so that we can have more simple parts. Now let's go and simplify that. Let's open the brackets. So this equals to what? This equals to what? Equals to, if we open that, it will be 9. This times that one is equal to 3 cot. That times 2, that is 6 cot x plus cot square of x. You can use Pascal's triangle or whatever, or you can just write the 2 and then simplify. You will also end up with this one, and that means there we have a 1. There we have a 6 cot x plus 9 cot square of x. Cot square of x. Now let's go on. That means there we have a constant, and also there we have a constant. Can we collect the 2? That means we are going to be left with 10. That means there we have that coefficient, that is 6 cot t, that is negative and that is positive. That means this one and that one goes. And we are left with what? Cot square and that 9 cot square. That means we are left with plus 10 cot of x. Cot of x. Can we factor out 10? Yes, it is very possible. 1, we are left with 1 plus cot square of x. But if you remember that much careful or that much correct, you will find that this one is also found in the Pythagorean identity. I will remind you, we have sine square of let's say theta plus cos square theta is equal to 1. That means if we divide there by sine and there by sine and all are squared, we'll be left with 1 plus cot square theta is equal to sec square. That means instead now of writing this one, we are going to write that one. So when you are doing your questions out there, you cannot do this every time. Just remember that 1 plus cot theta is equal to sec square theta. Remember that 1 plus cot square theta is equal to sec square theta, and then you just write it there. Now I will go on with that. That means it will be 10, and then sec square x. Sorry, sec square x. That is to say, therefore, conclude your question. Therefore, 3 minus cot x square plus 1 minus plus 3 cot x and all that is squared is equal to what? Is equal to 10 sec square of x. And that is your conclusion, my dear student. That is your conclusion, my dear student. Now let's see another case. Elimination of parameters. Elimination of parameters, as it's seen there. Now, elimination of parameters, what is that? It's a process of removing the common term or the common terms from the 2 or more equations by using simple trigonometric identities. I will repeat that. Elimination of parameter is the process of removing common term from 2 or more equations. So you'll be given a set of equations. equations and you are told to remove a certain parameter by using simple trigonometric identities. And what is a parameter? Parameter is a common letter that in the given set of equations. That means from a set of equations you are told to remove a certain parameter, and you will see from these three examples that follows. For example, there we have the example that says eliminate theta from the pair of the equations. We have the equation number 1. That means we have to eliminate theta from these two equations by combining by using the identities. That means we have x is equal to cos theta plus sin theta, and y is equal to that thing. We are supposed to remove a theta from there. Let's see. So we have a set that is x cos theta plus sin theta, and y, which equals to what? Sin theta minus cos theta. That means you are supposed to remove a theta. Now let's arrange this equation in this way. We have x equals to cos theta plus sin theta. Y is equal to sin theta minus. So we have to remove the theta. Now I will add the two equations. I will add the two. Adding the two, what are we going to be left with? We are going to be left with x plus y is equal to what? We have a positive cos but a negative cos there. That means adding the two, it will go equal to 0. And that sin theta plus sin theta equals to 2 sin theta. Implying that sin theta is equal to x plus y over 2. And let's go to the next step. I will subtract the 2. Subtracting the 2, that means you are going to be left with x minus y is equal to what? Subtracting the 2, remember we have a subtraction there. X minus y is that thing there. Then we have a cos minus cos. That means cos plus cos. That means it will be 2 cos theta. And then sine minus sine. Sin theta minus sin theta. That means equals to 0. That implies that cos theta equals to what? Equals to x minus y over 2. Now let's use our identities, as in the definition says that we are to remove that by the use of simple trigonometric identities. I will use the Pythagorean identity, that is sine square of theta plus cos square of theta is equal to 1. Squaring that, that means we have sine square theta and cos square theta. That means I will square that thing. That means we will be left with x plus y square plus x minus y over 2, and all of that is squared, is equal to 1. Let's simplify that more. That means x plus y square over 4 plus y x minus y square over 4 is equal to 1. Can we multiply the 4 to the both sides of that, and let's see how it looks like. So we have x plus y squared. Again we have x minus y squared equals to 4. And opening the brackets there, we have x squared plus 2xy plus y square plus x square minus 2xy plus y square. I know you know that. Then we have common terms, this and that goes, and then we are left with 2x square, 2y square equals to 4. Dividing by 2 throughout, we have x square y square equals to 2. So that is how we remove parameters like that. That's how we remove parameters like that. Let's see the other example that says remove the parameter m cot theta and y is equal to n cosec theta. Let's make the subject of cot and cosec. That means we have x over m is equal to cot theta, and also we have y over n is equal to cosec theta. If we square both sides, that means we are going to be left with x over m square cot square theta and y cosec square theta. But we know 1 plus cot square of theta is equal to what? From the Pythagorean identity. So what can we say from there? That means we can have 1 plus, so this is cot x equals to, and this is cosec, that means it's y. Then from there you can simplify and get much more easy expression, or that much more simple expression. And let's do that. So we have 1 plus x square over m square. So if we assume those are the constant, then let's collect the variables. This goes that side, that means we are going to be left with 1 equals to y square over n square minus x square over m square. We can use that. That means this will be equals to, I do hope you understand that. That means multiplying it that side, that means we are left with y square m square x square n square is equal to m square n square. You can put it like that way, or someone else can decide to leave it like that way. That means it will be a y square x square equals to 1. All of these two are correct because you have already eliminated the parameter that you were told to eliminate. You were told to eliminate the theta, and you can see there theta is not available or is not found anymore. That's how we eliminate parameters. That's how we eliminate parameters. Now, my dear student, I will leave you some few questions for you to practice, and the questions are very, very, very few and very, very easy. You can find other questions and practice more and more and more and more, because a lot of questions are out there. Now, let me leave you there as you were with me, Kimati, discussing trigonometric identities. Till next time, bye-bye.